Okay, locus part 2. What do we have here? We have a fixed circle with center O. Center O. Let me label things. This center is called O, and this point is point. This point is A, and that point is point M. That point is point M. Okay, just a minute. All right. This point is A, this point is M, and this point is center A. What do we have here? Simply, A and O are fixed. O is fixed point. C is a circle with center also it's fixed. We have this line over here. This line over here is called line N. Line N. And what do we have on it? We have a point A is tangent to the circle at point A. This line N is fixed line N. So the line is fixed and the point is fixed. The point A is fixed. And what else? We have tangent. When we have tangent, so what is this angle over here? It's 90 degrees, right? This angle simply, it is right angle. Let me see if I can. All right, this angle is 90 degrees. I don't know if, okay, I will do that later on. All right, this angle is 90 degrees because radius to the point of tangency is perpendicular to the tangent. So angle OAM is right angle, right? Let me write it here. Angle, measure of angle, right? The measure of angle OAM is 90 degrees. Why? Because radius is perpendicular to the tangent. At point of tangency. That's nice. What do we have else? We have M is a variable point on N. It moves on the straight line, which is on the tangent. M is variable. Find the locus of the midpoint of OM. That's really great. Let me first join OM and let me put the midpoint. Okay? Let me put the midpoint of OM. And let us label this point. Let us label this point as F, right? So this point here is point F. Okay? Where do this point move? Simply we have right triangle, and this is really nice. We have right triangle at A, and we have F midpoint. What do we call OM? OM is hypotenuse. And if we have median comes from the 90 degrees, the vertex which angle is 90, to the midpoint of the hypotenuse is called median. Median relative to hypotenuse, which is AF, is equal, its measure, its length is equal half the length of the hypotenuse. That's great. This means, by other words, that FA equal FM equal FO, because this is midpoint, so FO equal FM, and AF or FA is half OM. This means is equal to FO is equal to FM. But we don't care for FM right now because M logically it's variable, and and F is variable, but I need to find F in terms of what? In terms, or with respect to what? Let's say with respect to fixed points. So let me take FA equal FO. O and A both are fixed because O is a center, right? And A line L is tangent, is fixed tangent to the circle at point A, so A is fixed. A is fixed, F and O is fixed. F is variable. In the case FA equal FO. That's nice. That's simple. What is FA equal FO? If we have a segment AB, for example, and both are fixed, where can we put a point M such that it is equidistant from A and B? Now, at the midpoint, or here, or here, or here. In a case, it is always, right, equidistant, have same distance from A and B. If we join these points, we found that it is on the perpendicular bisector of segment AB. Same thing here. F is equidistant from A and O. FA equal FO. That's what we proved over here. So what is the locus of point F? Locus of F is the perpendicular bisector of segment OA. Because O is fixed, A is fixed. Let's see if that is true. Let me make trace for F, and let me animate M, because M is moving, right? Let me animate M on the straight line L. Look what's happening. Look what's happening. It goes all the way, right? Any point, anywhere, if M moves anywhere on line N, then what? Simply, let me do it by my hand. If F moves if M moves anywhere on the line L, then what is happening here? F is tracing a line. So the locus is a straight line. The locus of it is a straight line, right? Okay, that's nice. What's about this straight line? Look at FA and FO. They keep going like equal. They keep going like equal. Also FM equal to them, right? But I don't care. I can't find locus with respect to variable point, and M is moving. F moves on a line. What's about this line? It's always FA equal FO. A and O are fixed, so it moves on a straight line, which is the perpendicular bisector of what? Which is the perpendicular bisector of segment OA. Okay, can you see that? It's perpendicular bisector of segment OA. It's not keeping the tracing, but we can see it. Okay, we can see how it traces a line which will be the perpendicular bisector, right? Let me do it one more time. I'm moving M at any place on what? On the straight line N, which is the tangent. Look again what's going on. FA keeps going equal to FO, and F always on the perpendicular bisector of OA. See you next video.